Hi guys, welcome to Algorithms Made Easy. Today we will see the question remove duplicates from sorted list part 2. Given the head of a sorted linked list, delete all the nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. So in the example 1 we can see that the linked list has duplicate values for 3 and 4. And thus the output would not contain any of these values but will only contain the distinct values 1, 2 and 5. So is with example 2. The constraints given with the question are the number of nodes in the list will range from 0 to 300 and the values of node will be -100 to 100. And the list is also guaranteed to be a sorted list in ascending order. So now let's see how we can solve this problem. Let's take the first example and try to derive a solution out of it. So this is the given input list and this would be the output that eliminates the 3 and 4 nodes. So now what we do is we take a dummy node or a sentinel node and then point the next of dummy to the head of the list that we are given. Now with this we'll also take two pointers, previous and head. So the head of the linked list would be the head and the previous pointer is the pointer that will store the last distinct value that we have found. After this, we'll compare the values of head and head.next. If the values are equal, then we need to skip those values. So we'll perform some steps so that we skip those values. If the values are not equal, like in this, we move previous and head. So now previous becomes previous.next and head becomes head.next. Again here we see that the values are not equal, so we move both the pointers. Now in this case head and head.next becomes equal. Here we know that we have come to a place wherein we'll need to skip some nodes. So we just move our head for the next time. Here the head and head.next are not equal. So we can say that this previous node was the distinct node and that could be connected to the next of this head, which is also a distinct node that we have found. And in that process, we will be skipping these two nodes. So we put the next of head in the next of previous. Again now head will move one step ahead. Now here we see that these both values are also equal, so we need to even skip these values. So head moves and now here we get unequal values and so the previous will get attached with this distinct node that we have found. With this, the head.next becomes null. That means there are no more elements to process. So here we'll just return dummy.next. And dummy.next would now contain only these three nodes and rest of the nodes would not be connected to the next of dummy. So that's all about the approach that we'll be using. Now let's go ahead and code this solution. As we saw in the example, we'll need two nodes, a dummy and a previous node. So here the dummy contains the value 0 and its next is pointed to head. After this, we'll start our while loop. So while head is not null, so here we'll check that the head.next is not null and that if both the values are equal, we need to skip those values. So we write a condition for that. Here we need to skip the nodes that are equal. So we again take a while loop and see that head.next not equal to null and so while this condition is true, we do head equal to head.next. After we have done this, we do previous.next equal to head.next to connect the next of previous to head.next. If the values were not equal, we do previous equal to previous.next. And in every case, we also need to do a head equal to head.next. Finally, we return dummy.next. So let's try to run this code. So it's giving the right result. Let's submit this. and it got submitted. The time complexity for this approach is O of n, where we need to go through each and every node, and the space complexity is O of 1 as we are not using any extra space. So thanks for watching the video guys. See you in the next one.